Hello everyone, let's look at question 1. The question states, let A be a set containing the elements 6, 7, 8, 9, and 10. This question tests us understanding of basic 6 notation, the difference between an element and a subset. Option A says 9 is an element of set A. Since the number 9 is clearly listed inside set A, this statement is correct. Now, let's look at the other options. Option B says the set containing 6 is an element of A. This is incorrect. The number 6 is an element, but when you put it inside curly brackets, it becomes a subset. The correct notation should be the set containing 6 is a subset of A. Option C says 6 is a subset of A. This is also wrong. 6 is just a number, so it is an element, not a subset. Option D says the empty set is an element of A. Remember, the empty set is always be a subset of any set, but it is not listed as an element. Therefore, the correct answer is A. Now moving on to question 2. We are given two sets. Set A is the set that x is greater than or equal to -2 and less than or equal to 2. Set B is the set that x is strictly greater than 0. The main focus of this question is finding the union of two intervals. When we merge these two intervals, they overlap starting from 0, and it continues upwards forever because of set B. Therefore, the union is that x is greater than or equal to 2, -2. This perfectly matches option C. Let's look at question 3. This question tests your ability to solve an inequality. To solve this, our first step is to factorize the expression. The factorized form is x means 2 times x plus 1 is greater than 0. Setting these factors to 0 gives us critical rules. X equals 2 and x equals -1 image open upwards. Because the inequality is greater than 0, we are looking for the parts of the graph that above the x-axis. This occurs on the outside of the two critical rules, so the solution is x is less than -1 or x is greater than 2. Option A is the correct answer. In question 4, this problem tests your knowledge of arithmetic sequence. We have learned an arithmetic sequence. A sub 1 is equal to 2 and the common difference d is equal to 3. We are asked to find the 100th term. Let's review the general formula A sub n equals A sub 1 plus n means 1 times d. Now, we just plug in the given numbers. A sub 100 equals 2 plus 100 means 1 times 3. This simplifies to 2 plus 99 times 3. Finally, 2 plus 297 gives us 299. So the correct answer is A. Finally, let's look at question 5. The focus here is finding the domain of composite algebraic function. To find the domain, we need to satisfy two mathematical conditions to make the expression valid. First, we have a fraction 1 over x. The rule of fractions is that x can't be 0. So our first condition is x can't be equal to 0. Second, we have a square root. For real numbers, the expression inside a square root must be non-negative. So our second condition is 1 means x must be greater than or equal to 0. We get x is less than or equal to 1. Now, we combine these two rules. Let's express this in interval notation. The domain is from negative infinity to 0, union with 0 to 1. So the answer is option C. Now let's look at question 6. This question tests your understanding of geometric symmetry in the rectangular coordinate system. We are given a point P with coordinates 1, 2. We need to find the coordinates of point Q. Given that P and Q are symmetrical about the x-axis, when a point is reflected across the x-axis, the x-coordinate stays exactly the same. However, the y-coordinate changes its sign, so the x-coordinate remains 1, and the positive 2 becomes negative 2. Therefore, point Q is 1, negative 2. So, option B is the correct answer. Now moving to question 7. The focus of this problem is evaluating exact trigonometric values for special angles. First, sine of P over 3 equals the square root of 3 over 2. But the formula says sine squared, so we must square this value, which gives us 3 over 4. Next, cosine of P over 3 is exactly 1/2. Finally, tangent of pi over 4 is simply 1. So, 3 over 4 plus 2 over 4 equals 5 over 4. So the correct answer is C. Question 8. This question tests the concept of function parity, meaning whether a function is even, odd, or neither. The given function is f(x) equals x to the power of 4 plus 3. To determine parity, to substitute negative x into the function and see what happens. Let's calculate f negative x. It equals negative x to power of 4 plus 3. Because 4 is an even exponent, the negative sign disappears. This leaves us with x to the power of 4 plus 3, which is exactly the same as our original function f(x). So it is an even function. Therefore, the correct statement is option D. Let's look at question 9. This problem tests your ability to find the inverse of a mathematical function. We want to find the inverse function of y equals x cubed plus 3, where x belongs to all real numbers. Finding an inverse is a two-step process. First, solve for x, and second, swap the variables. Y equals x cubed plus 3. To isolate the x cubed, we subtract 3 from both sides. This gives us x cubed equals y minus 3. To get x by itself, we must take the cube root of both sides. So x equals the cube root of the quantity y minus 3. For the final step, we swap x and y to write it as the proper function. This results in y equals the cube root of the quantity x minus 3. Since we are dealing with a cube root, the domain remains all real numbers, so the correct answer is A. Finally, question 10. This is a fundamental question, testing for quadrants in a coordinate system. In quadrant 1, both x and y are positive. In quadrant 2, x is negative, but y is positive. In quadrant 3, x is negative, but y is negative. In quadrant 4, x is positive, but y is negative. Looking at our choice, option B is -1, -2, so it suits perfectly in the third quadrant. Therefore, the correct answer is B.